In this video, we're going to be looking at how we can create organic textures using Copernicus, and more specifically, how we can create rock textures. Now, this part, we're looking at how we can use noises to generate various features of a rock face or a rock texture. Now, there's a bunch of ways that we can use Copernicus, or COPS, as I'm going to be referring to it for the rest of the series. And COPS functions extremely well between the SOP level, the COP level, and our Solaris or stage level. So I'm just going to go ahead and firstly show you one way of working with it, and that is to just create a geometry node. And this geometry node over here is going to give us access to the SOP level. So we can just call this rock, and inside of here, let's create a COP network right over here. Now, when we place this, you won't notice anything in your viewport, and if you go over to your composite view, you won't notice anything over here either. This will throw you to the image level, so just go back to your object level, dive inside rock, and back to the COP net. Okay, so we can dive inside. Now, the easiest way to actually view something over here is to just place a constant. So if we place a constant over here, you'll see this white block, and we have some controls over here for changing the value. And you'll see that this node doesn't look exactly like the other Houdini nodes. That's because we have a left to right sort of workflow. So we're going to be adding nodes over here to the right, and this is our Copernicus network. You can see in the top right over here, Copernicus. So if we go up a level, you'll see that we still see this in the viewport. And that's because this is what this COPNet is outputting. And this over here is just a SOP node. So if we middle mouse on it, you can see that we have a position. But over here, we also have a volume. The volume is a 1024 by 1024 voxel volume. And that just represents the resolution of this image that we're creating. You can think of this as a very thin volume that's only 1 voxel thick, which is pretty much the same as having an image where each pixel is flat. Inside of here, we can make changes to this volume, but we treat it as an image. So if I just delete this constant, we can go ahead and create a fractal noise. A fractal noise is a really good starting point for generating a variety of looks. So this noise has a bunch of options over here, but the one thing that I do want you to be aware of is that this is a seamless noise. And we can actually test this. If we use a transform, we can plug this in over here. And if we decrease the scale of this, so we'll just reduce uniform scale, you'll see that it is a perfectly seamless noise. Now, this is great because we don't have to worry about creating a tileable texture. It will be tileable as is. So to begin with, let's go ahead and change our noise type. We'll change it to a Worley F2 minus F1 cellular. But because this is a fractal noise, we do have a lot of distortion coming from this roughness down at the bottom. So we can remove the fractal roughness over here so that we just have these cells. Now you will see that it is a little bit washed out. So go over to the top and increase the amplitude. As you can see, we now just have this pattern. From here, we can make further changes. I'm going to increase the element size until we just have something that looks like that. And now I want to distort this because we want more interesting shapes to occur over here to make it look more like a rock face. So what we're going to do is we're going to take this output over here where we have a noise, and we're going to make some adjustments to it with a distort. So you can see that we have our fractal noise, and we're plugging it into the source of our distort. By default, this distort will just pan this around, but if we give it a direction, then it will cause distortion in that direction. So an easy way to do that is by using another fractal noise. This one over here, we can just use Perlin. Let's increase the size, decrease the roughness, and over here, you'll notice a slight mismatch of signatures. Now, what does that mean? Well, if we look at the input that's expected over here on the distort for our direction, you'll see that it's orange, right? That's just a UV. This is a vector 2, but the output from our fractal noise over here is what is known as a mono or a float, right? So this is just black and white. To get a direction or a UV, we can go over to our fractal noise, scroll up to the top, and under signature, you can change this from mono to UV, that'll give you a vector 2, or to RGB, that'll give you a vector 3, or to RGBA, and that will give you a vector 4. So we want a UV that changes that to this orange output. We can plug that into direction, and over on our distort, if we now increase the scale, you'll see that it distorts along the direction of our noise. And if we do it like this, we can get decent results, but I'm going to do something slightly different. There's another way of working with this distort node, and that is using the distort by slope. So over here, we have distort by slope. It creates 2 nodes for us. Plug our noise back into the first input, and it'll throw an error. That's because this slope direction over here actually takes a mono height and converts it into a slope direction. So we can go over here and once again create a fractal noise, this time leaving it as a mono because these 2 signatures over here are matching. So we can plug that straight into the height, and you'll see that it distorts it a little bit differently. On our fractal noise, we're going to switch this to a Worley cellular, reducing the roughness, increasing the size, and then just giving it some offset so that it's different from our noise over here. Now you will see that the slope direction takes this that we've generated and generates slopes. So these slopes can then be used in our distortion over here. And if we adjust the scale, you'll see that they move towards those areas, right? So it distorts towards those areas. Now, I found that if you have these extremely sharp edges, one way of mitigating that is by reducing the angle over here to something closer to 0. And you'll see that it no longer has such defined features. The other thing that we can do over here on our fractal noise is reintroducing a bit of roughness, like that. And now it's just about adjusting the scale of this distortion. Now, of course, we can go back to our original fractal noise and everything is procedural. So we can reintroduce some noise if we want, or alternatively, we can make changes to things like our contrast or the center. So we're now going to take this and look at layering. So we have this already, but we want to add some more noise to this, and we want to start layering it up with other noises to add some variation and some interest to this effect. So let's go ahead and actually add another fractal noise. So we can add this fractal noise over here, and then a multiply. Now, before I drop this multiply, I just want to show you that it is actually the blend node. So if we drop this blend node over here, you'll see that it asks for a background and a foreground. We can take this into background and our noise into foreground. And by default, this just allows you to blend between the two of them, but there's a bunch of different blend modes. And we can do something like maximum, so it'll only choose the highest value between the two, or minimum, which only chooses the lowest value between the two. But what I want for this one is multiply, right? That's going to add some nice detail to these existing areas. So down here on our fractal noise, we can increase the amplitude to something like that, right? It's going to give us just a little bit more detail. So we just went from that to that. Now, what about these completely dark areas over here? It would be nice if we had a noise to fill in those areas as well. And we can do that. We can go ahead and create a new fractal noise down here. And this time we're going to use the maximum operation. So do keep in mind that this is once again just the blend node, but it has been set to a mode of maximum. So we plug this in to the background, our noise into the foreground, set our display flag, and now you'll see that it's only outputting our noise. And that's because there are no high values over here. So it's only taking all of the high values from our fractal noise. A good way to adjust this is by using a multiply constant. So over here, we can adjust how intense this fractal noise is. So you'll see that we can reduce the brightness, and as we do that, it'll start to fade away, right? So you can have something like that. We also have the option for shifting. So where brightness acts as a multiplier, shifting acts more as a subtraction, right? So you can see over here that these values will shift towards black or shift towards white, and so that gives us another level of control. We can also control the noise itself. So we can go ahead and perhaps increase the element size, increase the contrast, increase the roughness, and then over here, we can just reduce the brightness of that so that it just fills in those areas for us. Now, much like using maximum, we can also use minimum. So let's just go ahead and we'll duplicate our fractal noise over again, this time switching it to a Worley cellular F1. And if we get some nice details like this, what we can actually do is use an invert. By default, this does a complement, so it'll do 1 minus those values. And then we can use a minimum. So we can plug this in over here and our invert over here. And now you may not see these values showing up. And that's because these values aren't that dark. So what we can do is we can remap them. So use a remap node. And the remap node is really useful for when you have values that you want to change the range of. And if we just push up this input minimum, you'll start to see those details really show up. Then if we go to our minimum, you'll see that it's cutting in over there. We can also bring up the output minimum so that it's not so harsh. Okay, so now that we have this, we need a way of previewing this because it doesn't really look like rock at the moment. So how do we get this looking like something that we can use? Well, we can use a preview material right over here. If we plug this into the preview material, so we take this minimum value over here, we plug that into our base color, then set our display flag on our preview material, you won't really notice anything different. However, what this has done is it's generated a piece of geometry and applied this as a texture. So if we go over here and switch this to something like a sphere, you'll be able to see your texture applied onto the sphere as a material. So we can also change this to something like a torus, but for now I'm going to keep it as a grid. Now, if you really want to get an idea of how this looks as rock, we can take this and plug this into height at the bottom over here. You will see that this doesn't have enough divisions to actually give us a good result. And that's because over here, we only have 10 divisions. So we can go ahead and increase the divisions to something like 200 or even higher, something like 300. If for whatever reason, it's not updating for you, then what you can do is just break the connection to the height and plug it back in, and then it'll work. And then we can go over here, scrolling down to normals and displacement and just reduce the height scale, right? So to something like 0.3. Now we're starting to get an idea of what our rocks actually look like. However, we still don't have our diffuse, so our base color. We're currently just using this, and this is being used for both the height and the diffuse color, but that's not really what we want. So let's work on that base color. And one of my favorite nodes to use for this is the ambient occlusion node. So we're going to go height to ambient occlusion, and you can plug in this that you're using for your height into your ambient occlusion over here, and you'll just get this pure white square. That's because the height scale is off. We have values that range between 0 and 1 over here, so we need to increase this height scale all the way up until we can see all of our details. We can push it up even further than that if we want to something like that. You can also make changes to the view radius. This is just how far to search around an area to decide if it's occluded or not, and we'll end up with something like this. Now this already looks a lot better, but it's not exactly what we want. So what we can do is once again use a blend over here. This time we're just going to use the regular blend, and into it we're going to take our ambient occlusion, and we're going to take our height, and now we can kind of blend between the two, right? So I'm going to go somewhere around halfway, and that looks pretty interesting. And then we're going to put that into a ramp so that we can go from grayscale to color. So let's just use a ramp over here. We want ramp RGB, plug this blend into the position, and this is going to control where along the curve we're looking. So low values are going to be on the left side of the curve, high values on the right. Let's pull up the low end until we can see what we're doing. And now let's add some colors that look more like rock. So something like that. Then we plug that into our base color, and now we have something that looks a lot more like rock. Again, this is all procedural, so we can go back and make changes wherever we want. For example, decreasing the amount of rock features or increasing it, increasing or decreasing the element size of any of our noises, reducing how much of a cutout effect our noises have, just like that. Now, you will see that this is very shiny, and that's simply because our roughness over here under specular is 0.5. If we want to adjust our roughness, a good way to do it is simply by taking our height and inverting it. But we're going to be using a remap to invert this, because if we just plug this in over here, all we have to do is swap this around. And the reason we're doing this is because we want these dark areas over here to be rougher, right? These are the areas where sediment will collect, so they tend to be rougher. The areas that are exposed to elements tend to be a little glossier or shinier. So we just invert this so that these bright values, which are our higher points, end up with a lower roughness, right? So we have something like this. Then we can just take that, plug that into roughness, see what we have, and just bring down the input max, right? So we can bring it all the way down. And then over here, we don't want our output to be completely glossy, so we can pull this up a bit. And now we have some of these shinier areas. Now let's preview this on something other than a grid. So let's just change this to a torus, and there we have it, right? And because we've worked with noises the entire way, this is perfectly tileable. So if we increase the UV scale on this torus, you'll see that there's no visible seam to our actual texture. Okay, so now that we have this, I can go ahead and make a few adjustments to this until I'm happy with it. Just adjusting the ranges for our different noises and our blends and our colors and all of that. And then we can go ahead and look at ways of rendering this. So we can either render this directly as this torus or apply this to our own geometry. So I'm going to show you how to do both of those right now. All right, so as we discussed, this preview material applies our textures to a particular geometry as a material. So it creates a material setting all of the values that we've input as values for a material which it applies to a geometry. The geometry in question is a torus. And you can actually see this if we look at the preview material. Much like how we had outputs being things like mono or UV or RGB, we also have geo as an output, right? So it's an output type. With our display flag on this preview material, if we jump up to the sub level and we middle mouse over here, you'll see that we no longer have a volume like we did when we started. We now have geometry. We have 700,000 points, we have 700,000 primitives, and a bunch of attributes, as well as a material path. So switching your display flag back to one of these will once again output just a volume. But because we have it set over here, and the output for this is a geometry, we get a geometry out of our COP network, which is really interesting because that means that we can work with it further after our COPNet. And I'll give you a very basic example. We could do something like an attribute noise, where we adjust the position, right? Just to prove that this is actually geometry coming out of our COP network. So this is just a taste, I suppose, of how much of an integration there is between COPs and SOPs, and how you can go back and forth between the two. This also means that if we wanted to render this out, it's really as simple as just going to our stage level, importing the entire scene, so we can do a scene import all. It'll bring this into our viewport for us over here, and now we're at the stage level. So we can add a camera, we can add a calmer physical sky, and we can start a render. And just like that, we have it rendering in our viewport. Now keep in mind, any changes that we make over here in our COPNet will reflect in our stage level. For example, If we just change this color over here to something of a blue tone like this, and then we go back, you'll see that in the crevices, we now have the sort of bluish dirt, right? So you can make changes and it's very quick to go back and forth. Now, one thing to take note of is that if your displacements don't look very good over here, that could be just because we don't have a high enough dicing level in our render. So we can actually change that by using a render geometry settings. All we have to do is select the primitive to effect. So we can do /rock, and then we just scroll down all the way to dicing, set or create dicing quality, set it to 1. And if you give that a moment to initialize, you'll notice that we have much higher fidelity displacement. There we go. So our texture now comes through a lot better. Now, the only other thing is what happens if we have this material and we want to apply it to some other geometry. Now, there are a couple of ways of doing this because we do have this being brought in as a material now. But I'm going to show you some other ways of doing it that are a bit more intuitive. So if we remove this scene import all, I can just go ahead and create a brand new geometry. So let's go and use a sop create. We can rename this to custom geo and plug this in over here. Dive inside of the sop create, and let's just use a pig head, test geometry pig head right over here. So jump up a level and we just have this pig head floating in space. It doesn't have any materials attached to it. So how can we go about attaching materials? Well, the easiest way right now would be to use a quick material. So quick surface material. This is new to 20.5, and this just allows you to create a material without having to create a material library or anything like that. So all of these settings are now exposed to us at the Solaris level. So with this quick surface material, we can just rename it to something like rock material. And that's just because the primitive path over here will be set to materials, rock material. We do want to assign this to our geo. So we can use an assign material, and it's really simple. We just go over here. We'll do /custom geo. And for material path, we'll do /materials /rock material. And to test if it's applied, we can make changes to this rock material, and it's working. So now, how do we actually fetch our materials and use them over here? Well, if you take a look over here, we have this color map option. We can set or create. By default, it'll just throw on this checkerboard pattern. But if we go ahead and take a look at the actual color map option towards the right over here, you'll see that we have a file chooser. We can actually choose a color map or a texture, but we also have a create cop texture. Now, if we click on this, you'll see that it applies this material over here, but it also creates a cop network over here. If we dive inside, you can see that it actually generates all of these things inside of here. And you could very easily just create your textures inside of here. You could even copy and paste the textures that we've already created and paste them in here, right? So this is just another way of working. This is extremely intuitive. You just create your quick material surface. You go over here and you just say, create a cop texture for this particular map. And then diving inside, you have access to it over here. Now, we're not going to do that, but I do want you to take note of an important piece of syntax. This over here is what allows us to choose a particular path and use it as a texture. So if you remove that up part over there, it'll no longer work. Even though the path is still correct, we need that as a prefix for this to actually work. So let's just clear this and delete the cop network. And let's go set up our cop network so that it's easy to reference. Let's just create some nulls. So we can create 3 up here, and I'm going to minimize them so that they're smaller. We'll just make 3. We'll have 1 for our base color. We'll have 1 for our roughness, and we'll have 1 for our height. Now we can just take these over here. So base color will go into base color. If we take a look at it, it's just that. Into our roughness, we will of course be grabbing our roughness. And into our height, we'll be grabbing the height. Just like that. Right, so we now have all 3 of them being output. And so the easiest way to actually get a reference to this or a path is to click on one of these and press Ctrl+C. What this will do is it'll copy the location. So we can go over here to our stage level, go to our rock material, and under the color map, we can just press Ctrl+V. That'll paste the location. Remember, we do need that up in front, so up : and there we go. It now brings it in. So we can do it for the rest of them. Under specular, we don't want a color map, we want a roughness map. So set or create, op : paste. And we don't want base color, so we'll change that to roughness. And the other thing that we want is to just push up our roughness to a value of 1. That's simply because roughness maps work as a multiplier of this roughness, so we want to make sure that this is a value of 1 being multiplied by the values that we have. Then finally, we'll go down to bump, and over here, bump height map, we'll once again do up, paste, and we don't want base color, we want height. Now, you won't see much of a change just yet, and that's because our bump scale is very low, so let's do 0.3, and set this to true displacements. Now, if we go all the way down over here, we can also make a change to our render geometry settings. And the only thing that we want to change is that we're now going to change the dicing not on rock, but on our custom geometry. And let's take a look at this through our camera, Karma XPU viewport, and it's now applying our texture to this pig head. Now, of course, the UVs on this pig head might be a little bit big. So what we can do is dive inside here, and we can do something like a UV transform, scaling it up a bit, maybe something like 4, go up a level, and we now have that rock texture applied to our pig head. And you'll see that with our dicing enabled, we have a much higher quality displacement. And the really cool thing is now we can just replace this with whatever we want. We can put a rubber toy in here, and it all just works. So a quick review of what we're doing. We're creating a geometry, we're creating a material. In this material, all that we're doing is we're setting a color map, and we're setting it to the location inside of our COP network for our base color, right? We've created a null called base color, and if we take a look at it, it's just this over here, right? So it's calling this into our Solaris level, into our material. We do the same for the roughness, we do the same for the height. We then assign this material to our geometry. We set up a camera, lights, and we increase the dicing quality by selecting the primitive called custom geo and increasing the dicing quality to a value of 1. And after all of that, we have a material that can just be applied to any object at all. Okay, so that's how we create a rock material using COPs. In the next part, we're going to be looking at how to create a dirt texture, and it's going to pull on a lot of similar concepts, but we are going to be looking at how we can rasterize geometry. So say we want little pebbles or twigs or whatever it is inside of our dirt. How do we take actual geometry, rasterize it, put it into our texture, and then have that render? We're also going to look at what sort of issues that poses for tiling, but we'll be tackling all of that in the next video. So I'll see you there.